All right, I think I just started recording, so let's go ahead and fire this up. Good morning to everyone. Today's lesson is in terms of standard 22, focusing on areas between curves using definite integrals. So before we go ahead and get started, I have a GeoGebra link I'd like to share with you. So what we have here in this picture is a function y equals f of x, bounded on the left and right by x equals a and x equals b. As I move the slider here, let's talk about what happens. So this region here in cream or beige, whatever that color happens to be, is given by the definite integral from a to b of f of x dx. The geometric application of a definite integral is the area under a curve. Now I'm going to keep sliding and introduce a second function. A second function, this line y equals g of x. And as I shade this in pink, the definite integral from a to b of g of x dx gives the area under that linear function. What about the area between these two curves? As I shade here in green. The area between the two curves with the function f of x on top and g of x on bottom. How could I use a definite integral to evaluate and compute the area between the two curves? Well, it's not too terribly different. It's just one function minus the next, top minus bottom. The definite integral from a to b of f of x minus g of x dx gives us the area in green between the two functions. So today I'd like to look at a couple of applications, a couple of sample problems on computing the area between two curves. If you haven't already, it might be worthwhile to pull up a Desmos graph. Since this is such a visual activity, you're able to use Desmos as much as you'd like to assist you in solving some of these questions. All right, so this is actually problem number 8 in the S22 practice problems, but I thought I'd do it just because it provides a good sample question. And our focus here is once again to find the area between these two curves. So I have f of x equals the square root of x plus 3, and g of x equals 1/2 x plus 3. What I want to know, as I can see on this GeoGebra document here, is where do these two curves intersect on the left and right? That's important because it defines the upper and lower bounds of our definite integral. From what to what gives us the region for the area between the two curves. So we can simply set these two equations equal to each other to find the intersection. Where is the square root of x plus 3 equal to 1/2 x plus 3? Now I can see if I subtract 3 from either side, that cancels out. Then I'm left with the square root of x equal to 1/2 x. I'll need to square both sides. The square root of x squared is x. 1/2 x quantity squared would be 1/4 x squared. To keep solving, we'll set one side equal to 0. And what I might do next is clear out the fraction. Multiply each side times 4. That would give me 0 still on the left, and x squared minus 4x on the right. To solve by factoring, I'll have 0 equals x times quantity x minus 4. And our two solutions are where x equals 0 and x minus 4 equals 0. So that would be at 0 and 4. These two functions intersect, meet for when x equals 0 and x equals 4. We can confirm this by looking at Desmos and typing these two functions in. So looking here, I can see that for when x equals 0 and 4, these two functions are equal. Defines the area between the two curves that I can see right here. What we're trying to do is find the area of this region. So let's go ahead and set up our definite integral. I know the upper and lower bounds are 0 and 4. That's the whole point of finding where these two curves intersect. Now, as I can see here on the GeoGebra screen, I need to do one function minus the other. And since subtraction isn't commutative, order is important. I do f of x minus g of x because f of x is the function on top, g of x is the function on bottom. If you do get these switched around, it's really not a big deal because your answer would just be the opposite. It would be a negative value from what the true area would be as a positive. Back on Desmos here, I can see that the f of x square root function is strictly greater than our g of x linear function between 0 and 4. So back here, we'll do square root of x plus 3 minus 1/2 x plus 3 dx. This would be the definite integral that gives us the area under the curve. Let me stop here for a minute. If there are any questions, we've kind of got this set up. So I'll pause. If you have any questions, now would be a good time to ask. Okay, let's keep going. The rest of this is just using fundamental theorem to evaluate the definite integral. I notice right away, if I try to simplify that, the 3's cancel out. So I'll bring down the definite integral from 0 to 4. Of the square root of x minus 1/2 x dx. The antiderivative is what's next. The antiderivative of the square root of x, let's think of that as x to the 1/2. Its antiderivative would be 2/3 times x to the 3/2 I now need the antiderivative of our next term, 1/2 x. The antiderivative of 1/2 x should be 1/4 x squared. We'll need to plug in 0 and 4. So on the next page, let's go ahead and do that. I'll need 2/3 times 4 to the 3/2 minus 1/4 times 4 squared. If I were to plug in 0, if I were to plug in 0, 0 to this function, I would just get 0. So it's really not necessary to plug in 0 because when I subtract 0, it doesn't really change anything. So let's go ahead and start evaluating this. 2/3 times 4 to the 3/2. That's the square root of 4 to the 3rd power, which makes 8. The square root of 4 is 2. 2 to the 3rd is 8. 4 squared is 16. A quarter of that is 4. Once again, minus 0 doesn't change anything. 2/3 times 8 is 16/3. I'm going to go ahead and find a common denominator. In terms of thirds, 4 is equivalent to 12/3. And our final answer here is 16 minus 12, or 4/3. The area between the two curves is 4/3. We can check that on Desmos to confirm our answer. INT is the shortcut for a definite integral. You could also find that on the keyboard here under the Functions tab. I believe under Miscellaneous is this antiderivative definite integral option. Between 0 and 4 of quantity f of x minus g of x dx is 1.3 repeating, or 4/3. That 4/3, once again, is the area of this region right here. Let me stop there. Was there any thoughts, problems, questions that we need to talk about before I do anything else? It's very similar to using a definite integral for the area under one curve. We're just doing two curves at the same time and taking the difference. Okay, if not, I think I had one more sample question that I'd like to run through with you. So I'll clear this out. And let's try another one. On this question, we're asked to find the area of the region bounded by the graphs of x equals 3 minus y squared and x equals y plus 1. So right away, I notice a couple of things. Rather than functions in terms of x, these are two functions in terms of y. We're not asked to find a horizontal, we're not asked to find a vertical area, but a horizontal area. Let's type these into Desmos, and I think you'll get a better picture of what I'm talking about. X equals 3 minus y squared was our first function. Is that right? Yep. And x equals y plus 1. So rather than our functions running vertically, as in our previous example, now these two functions are running horizontally. So rather than a top and bottom, I have a left and right function. So we'll begin this much the same way. Let's first figure out what are the bounds where these two functions intersect. So where is 3 minus y squared equal to y plus 1? Well, this is a quadratic function, so I'm going to go ahead and get 0 on the left by adding y squared, bringing down the y, and then subtracting 3. 1 minus 3 is minus 2. This should factor into a pair of binomials. What multiplies to negative 2 and adds up to 1? That should be 2 and negative 1. So this has solutions for when y plus 2 is equal to 0 and y minus 1 is equal to 0. So therefore y equals negative 2 and y equals positive 1. We can confirm that by looking at Desmos, because now we're not looking at the x coordinate, we're looking at the y coordinate of the intersection. Negative 2 to 1. Now, as you can see here on the GeoGebra link, when I do a vertical area between two curves, it's top minus bottom. But this has been rotated. We're doing a horizontal area between two curves. So instead of top minus bottom, it's going to be right minus left. The red function here to the right minus the blue linear function here to the left. If that's confusing to you, figuring out which function minus what, just think of a number between negative 2 and 1. Plug them into each of the two functions. A good example of that would be 0. Plug in 0 for y. Whichever of these two functions has a greater value for when y equals 0, that should be the first function when you set up your definite integral to evaluate the area between the two curves. So when I plug in 0, 3 minus 0 squared is 3. When I plug in 0 for y here, 0 plus 1 is 1. The red function, 3 minus y squared, gave me 3. This gave me 1. So this function is strictly greater than the blue linear function between y equals negative 2 and 1, which is why I have this function further to the right when I look at the graph. So setting up this definite integral between negative 2 and 1. Of which function minus what? Well, we just talked about that. Right minus left, 3 minus y squared. Minus quantity. So that was y plus 1 dy. All right, that's pretty much the setup. I'll pause again. Are there any questions on how I'm getting this definite integral put together to find the area between the two curves.
So when we're finding the bounds,
Yeah.
is it basically always going to be the curve is going to be first in your equation and then the line will be second?
Not necessarily. That's just kind of a coincidence here. It's just which function is
Okay.
greater than the other. If I was looking
Okay.
here, we tested a number between -2 and 1. We plugged in 0. I want to know which function is greater than the other between these two bounds, -2 and 1. Try 0. Well, when I plug in 0 here, I get 3. When I plug in 0 here, I get 1. Well, this gave me a higher value, so I put that function first. If you do get those two switched around, like say I put these in the wrong place, right? You're just going to get the exact opposite. You're going to get the negative of what the true area would have been. So if I, on the previous example, if I had switched these around, I would have gotten -4/3 rather than +4/3. Well, obviously area can't be negative, but just assume that the answer would have been 4/3 anyway, okay?
Yeah, so just if I get a negative answer, I know I just
Yeah. As long as you did the calculation correct, the answer is just the opposite. But, it's not too hard to look at Desmos and figure out which function needs to go where. If you're doing a dx, it's top minus bottom. If you're doing a dy, it's right minus left, because you've just been rotated along your axes to make it a horizontal area. Okay?
Okay.
Oops, let's put this back here. Was there anything else? Good question. Okay, if not, I'm going to go ahead and keep simplifying. So I'll bring down the definite integral from -2 to 1 of -y squared minus y, and 3 minus 1 is a positive 2 dy. Now let's find the antiderivative. Let's see, -y squared would be -y cubed divided by 3, or -1/3 y cubed, minus y squared over 2 plus 2y dy. Now, unfortunately, oops, let me do this here to evaluate between -2 and 1. Now, unfortunately, this isn't 0 anymore, like our previous example. I'm going to have more work to do because I do need to plug in both the upper and lower bounds. Usually, if one of those is 0, you only have half the work to find your final answer, but that's not the case here. Let's start with 1. When I plug 1 in, it should be -1/3 minus 1/2 plus 2. Okay, be careful plugging in a -2. We're going to have some negatives, powers of negatives to deal with. When I plug in -2 into y cubed, that makes a -8, but this extra negative out here makes a positive 8. So that should be plus 8/3. So minus the 8/3 got first. When I plug in a -2 to y squared, that makes a positive 4, but this extra negative means I have to subtract it. So minus 4/2. Plus 2 times -2, so that would be plus -4 or minus 4. I'm going to go ahead and convert this into a common denominator between all of these terms. Looks like my common denominator is going to be sixths. So let's do that. Let's see here, -2/6 minus 3/6 plus 12 sixths minus 16 sixths minus 12 sixths minus 24 sixths. Let's simplify this part first. -2 minus 3 is -5. 12 and -5 make 7 sixths. Minus whatever I get when I simplify this part. 16 minus 12 is 4. 4 minus 24 is -20 sixths. 7 minus -20 is a positive 27 sixths. I can reduce that, divide it by 3, so I think that's going to be 9 halves, or 4.5. All right, 9 halves. We can use Desmos to confirm our answer. I want the definite integral between -2 and 1 of quantity 3 minus y squared minus y plus 1 dy. Yep, there's the 4.5 or 9 halves we got by hand a second ago. Any thoughts, problems, concerns working through that definite integral calculation for the area between the two curves? Okay, tell you what, let's do this. I'm going to pull up Schoology. We've got about another, I don't know, 10, 15 minutes before I need to hop on to my next call. Let's pull up some practice questions, and maybe I'll have you guys give you a chance to try one on your own. I'll kind of work behind you here. Give you one to try on your own to see how you're doing.
Do you think that I could take this after the stats call today?
This quiz?
Yeah.
Yeah, sure.
Or okay, maybe.
Yeah, if you want to do this afternoon, I do have another call from 1 to 2, but we could do it after that or anytime tomorrow. I'm wide open tomorrow. Whatever works best for you,
Okay.
Audrey.
Probably just right after stats today.
So like at noon?
Yeah.
Yeah, that should be fine. I'll just probably have to eat lunch while you're doing your quiz, if that's all right.
I do not care.
Do not care.
Do not.
Well, for some reason, Schoology's being a pain right now. Not sure why it's not working on this laptop, but I have another laptop here. If you get onto Schoology, why don't you guys try question 3 off of the S22 practice? And I'll just recopy it right here. This is problem number 3. Find the area between these two curves, y equals x squared minus 1 y equals negative x plus 2. X equals 0 and x equals 1. You can find the document if it opens for you. Awesome. If not, it's problem number 3. I've got it highlighted and it's also written right here. Take a minute, work through the calculation there to find the area between the two curves. I'll give you a couple minutes head start and then kind of work behind you to get the answer. If you have a question, please do speak up. All right, let's go ahead and get this graphed on Desmos. All right, so it looks like I'm trying to find the area of this region, kind of where all of these different functions come together. They give me x equals 0 and x equals 1. That kind of like acts as the left and right bounds of the two functions. So setting this up, I'll have the definite integral from 0 to 1 of the top function minus the bottom. And it looks like this function in blue, negative x plus 2 is on top, and x squared minus 1 in red is on bottom. Should be the definite integral to give us the area between the two curves. If I simplify this between 0 and 1 of negative x squared minus x, 2 minus negative 1 is 3. So we need to find the antiderivative as negative x cubed over 3 minus x squared over 2 plus 3x between 0 and 1. Got a nice 0 right here, so this is going to be pretty easy. We just need to really plug in 1. Negative 1/3 minus 1/2 plus 3. minus 0, because when I plug in 0 to our antiderivative, I basically get 0. See here, write this in sixths, so negative 2/6 minus 3/6 plus 18/6. Eighteen minus 5 would be 13. Sixths. And I can for sure confirm that on Desmos, 13/6 as the definite integral from 0 to 1 of quantity negative x plus 2 minus quantity x squared minus 1 dx. 2.16 repeating, or 13/6. Were there any questions, problems? Working through some of those definite integrals. Area between two curves. Okay. I would for sure try and practice some of those problems on the S22 document on Schoology. We'll do some more review and work on Wednesday. And then I do have an S22 quiz planned for Thursday if you check that calendar. Audrey, I emailed you a Google Calendar event for your quiz if you want to do it at noon today.
Are we done on this call?
Yeah, I'm pretty much done. Unless anybody had a question or two they needed to talk about.
So this is it? We're not covering last week's stuff, or we are?
Last week's stuff is the same as this stuff. I did 2 weeks for S22.
Oh, I mean the last test.
Last test, that'd be net change, displacement, total distance, average value.
Yep.
Nope. Each quiz is just one standard at a time. I'm going to do one quiz per standard unless you wanted to reassess as we kind of get through this last part of the school year.
Okay.
Was there anything else?
Should I just stay on and take it now?
I have to do my stats call here in about 15 minutes. So if you can wait till noon, that would be great.
Cool.
Okay. If not, guys, have a good rest of your day. We'll talk to you again Wednesday.
See ya.
See ya.
Thank
you. Have a good day.